So we're going to have to break these up into the x and y components, right? So the first thing that we should do is we should have a table of some sort that lists out all the forces that we have. Force 1, force 2, force 3, if we have such. And we can have as many forces as are listed in the problem. In this case, we only have force 1, force 2, and the resultant force. Here we have our x component, y component, and z component. We're just making a table for your forces. So what we're going to do is we're going to find the x, y, and z components for force 1 and force 2 individually. And when we find a component, we put it in our table. We line up everything all nice and neat. And then we just add. It's kind of like we're back in grade school where you have your number plus number over number. So you just add straight down. And that will give you the resultant force. And in this case, do we know the resultant force?
Yeah.
What are we looking for? The force 2. Yeah, so it doesn't give us this one. So we don't know what these are, but we can still find it because we're good like that, right? So let's start with the resultant force.
Negative 300 in the x.
What was this again? 269?
Yeah, 269.
Look at me being fancy with my pencil.
300.
Negative 300, 650, and 250.
250. So it gives us the answer, so that's nice of them. So we need to find our force 1, the x, y, and z component. Does it give us the magnitude of the force?
750.
750. Now this one, it's kind of hard to see because it's basically a 2D drawing of a 3D model. And so it's really hard to visualize it on a piece of paper. So this is where it comes in handy to really visualize what you're doing. So what is happening is from the x-axis on the xy plane, you have that 30 degrees coming out like that. 30. And then from there, from this line, this imaginary axis, it goes downwards by 45. 45. So we need to basically move the force up and over into its respective place. We do that by doing some trig. If you can imagine this in your head, will be a triangle, a right angle right there, and we want to find this length, kind of like how we've been doing in 2 dimensions. We want to find that length right there. This will be in the x and y plane. So we're going to have this, take this 750, times it by the cosine of 45. And that'll bring the force, that 750 newtons, up into the xy plane. But that is not in the x or in the y direction. So we need to take the cosine and sine, depending on which way you want to go. We have to do the cosine of that, because this becomes our new force, the new magnitude. So we do the cosine of the angle. So here's your little triangle again. And that'll give you the force in the x. So then x. So if your x is equal to, whatever this is equal to, the 750 times the cosine of 45 times by the cosine of this angle right here. So basically what you did, you started off with this, you brought it up into the xy plane, and then you push it into the x direction with this one. And so if we wanted to find the y direction, we'd do the same thing. We did the 750 times cosine of 45. So that takes it from its original spot, right there. Then it brings it up into the xy plane. Then if we wanted to push it into the y, instead of taking the cosine, we take the sine of 30. And that is the x component of that force, the one-dimensional direction, I guess, the magnitude of it, in the x and in the y. And if we wanted to get into z, if we had that 750 and we brought it up with the cosine of theta, if we took the sine of theta, it would push it down. And it just so happens that when we push it down, it becomes parallel in that direction of the z. Have you seen the model? Have you done with the model before, Hector? The connects model?
Oh, yeah.
Did that, okay. Because it is really hard, honestly, in my opinion. When I took it, go back. When I took this class, I remember that this was one of the hardest things to visualize, honestly. So that's why I brought these to school. And because it's kind of fun to just mess around when you're not doing anything. So here's our model of our axis, coordinate axis. Here you have your x direction, your y, and your z. So what we did is we had to take this is our 750 newtons. We had to take it and move it up into the xy plane. So first it was at 750, then we take the cosine of 45, that angle right there, up into the x and y plane. Then if we take the cosine of that angle, it will move it into the x. If we take the sine of that angle, it will move it into the y. Then once we're back in the beginning, if we took the cosine of this angle, this cosine 45, cosine 45, to bring it up, if we take the sine of 45, it moves it straight down into the z. And so that's how actually we get the z component. So if we were just put these individual these numbers up here, this is our x component, this is our y component, and this is our z component.